ಎಲ್ಲಪ್ಪ ಇದು ಅಲ್ಲಿದೆ. Okay. Voice clear? Voice is clear? First tell. Why? No response? Okay. We'll start now. Last time question. See, isolated footing. You should tell the dimensions for me now. See, this is the footing. See, it's a footing slab. Already we finished bending and all. See, footing slab here. This is a column. Okay. Somewhat out of scale. A scale not required. See, you should tell first value. What is the final L1 you have taken? How much? And also you should tell L2 value. L1, L2, how much? L1. How much L1? Good evening. How much L1? L1, last exam. Values you have to give because otherwise you can't continue. I told you should make note of all those things for continuation. I cannot remember because I have to once again go to YouTube. I have to see that class and come back. It will take a lot of time. How much L1? Last time question, we finished punching shear and 4.1, 3.6. Little fast. This is 4.1 meter. This is 3.6 meter. Anybody can tell the column dimension? One of the dimension is 0.23. What is other dimension? Column. One of dimension 0.23, other dimension. For the column, other dimension. I think 0.23 correct. Is 0.23 correct? No, one side is 230 correct? Column. No, column, one side, 230 is correct. Other is 0.75 in meter. 0.75 meter. See, therefore, see, this projection and this projections already over. Okay. And also, this projection already over. You know it. No point in once again calculating. See, I will calculate it, I'm asking. 4.1 minus 0.75, 4.1 minus 0.75 divided by 2. These two projections are 1.6, not here, I write somewhere else. Now, because there's a reason. See, these two projections are known. See, we took one strip here. I put everything here. We considered one strip here. This is the strip for lengthwise bending. Light line I am writing. 1 meter strip here. We took one more 1 meter strip here. That is for widthwise bending. See, this way. This is the 1 meter strip for, this is for lengthwise bending. This is 1 meter out of scale. Somebody may comment. Little bigger. Scale problem. Okay. This is for widthwise bending. And then when you take lengthwise bending, See, your cantilever was like this. See, how you can see? Column you can see here. You can see column, if I project column, footing slab is here. Okay, footing slab here. Then, this projection and these projections are 1.675 meter. You just tell me correct or wrong. 1.675 meter. When you take widthwise bending, you can see column side here. See, this way. Footing comes this way. This is 0.23. This all over already. Everything over. Okay, now, at that time, this projection and these projections are 3.6 minus 0.23 divided by 2. Slightly changing. 1.685 meter. This also 1.685 meter. And for lengthwise projection, we took a cantilever. See, we took a cantilever here. And actually what I have done is, first I took the pressure diagram. Pressure diagram. Pressure diagram is like, I think pressure is more that side, correct? Lockwise. It was like this, out of scale. Okay. This was the pressure diagram. Remember, everything is told for you. This is a pressure diagram. I am not writing once again. This is the pressure diagram for this 1 meter strip. Repeatedly told. Pressure diagram for central 1 meter strip. How you got this pressure? How you got this pressure was by this pressure here, and pressure here. That is average widthwise. Here also average widthwise. Get the pressure. You plotted here. Then you also got this pressure by interpolation. Then see. Then we took a cantilever here, one cantilever here, and one cantilever here. Action. And we decided both are of equal projection. Therefore, since both are of equal projection, bending and shear will be more for that side where upward load is more. If the distances are not same, projections, that is the case if the column is placed a little eccentric, too much eccentric not allowed, little eccentric. Then I give an example earlier. See, it is possible that where projection is more, first of all, I need not tell, where projection is more, pressure can be lesser. Where projection is lesser, pressure can be more. Then, based on projection, higher projection is critical. Based on pressure, higher pressure is critical. So you cannot tell. Then I told you, you find BMSF here and also BMSF here. Design the worst case, that is higher values. Now, in the class, all those we are not doing. Why? If such a thing happens, this is the class for software, ETABS&SAFE. Therefore, all you have to do is place the column wherever it is. If it is not exactly concentric, slightly eccentric, ETAB will take care of all those things. ETAB will take care of all those things, and it will calculate this BM, and shear force also, it will consider the higher value. In the model later, I will explain. In the ETAB class, I will explain that one. But here, basic knowledge sufficient. See, now, therefore, we told this is not required. Here, the pressure is, tell me, only this much pressure. See, only this much pressure. See, here pressure is lesser, not required. Tell the answer here. What is the pressure here? First, pressure here. How much? What is the pressure here? I am seeing, see the absent-mindedness. Absent-mindedness means what? I am holding the calculator in my hand. In the calculator, I am waiting for reply. Calculator, how it can give reply? That is called what? Absent-mindedness. How much? Tell me. You tell me this pressure. What is the pressure here? We got it. This is what? Don't give wrong values. One other should confirm it. 140 point. Allu Chaukasi. 3-4 values. If you give 3-4 values, what I can do? See, already you have done it. ಈ ಥರ ಒಬ್ಬರು 115 140, ಇನ್ನೊಬ್ರು 140, ಇನ್ನೊಬ್ರು 110. ವೇರ್ ಐ ಆಮ್ ಆಸ್ಕಿಂಗ್ ಇನ್ ದ ಸ್ಕೆಚ್. ಸಿ ದಿಸ್ ವೇ ಬೆಂಡಿಂಗ್, ವಾಟ್ ಈಸ್ ದ ಪ್ರೆಷರ್ ಹಿಯರ್? See again, if this way you give odd values, when someone will watch the video later, class later, they will tell, last time it was this way, suddenly change to this one. See problem. You should make a note, at least diagram or screenshot at least. Last time screenshot will do. Now see, somebody telling 110 and 160. Someone is telling 115 and 140. What I am asking? Pressure here I am asking. You are not telling answer. I am not asking both the pressure. I am asking pressure here. Length, this, see, what is this ordinate I am asking? Allu, 2-3 different values. What I can do? If such a thing happens, very difficult to take live class. Or I should make a note. I should prepare the question. In my entire life, I never took one class by preparing. Preparation class I never take. I never, have you ever seen, those who know me, have you ever seen bringing kits to the class or written matter? Even a single class, written matter in a paper, I will write everything and bring it to the class. I never do it. 140.51. Now, if it is wrong, it is a problem now. 140.51, okay, kilonewton per meter square. Then I am not asking what is the pressure here. Later, when I consider this cantilever, you got a pressure here. Tell this pressure, I require it. Why? I am going for shear, that's why. I want, someone told 160.28. Class cannot be continued, sorry. Class cannot be continued. If you give this way wrong value, class cannot be continued. No, I cannot continue the class. You should have taken a screenshot at least. Even if it is a wrong value, no problem. What wrong value taken last time, same I should take. Because when anybody will start study, continue, last time see different value, now see different value. Now you are forcing me to open that class and see it. What to do? See, I should go to YouTube now. I should cancel this one. Then I should go to that class. See, where is it? I don't know. I should go to my RCC footing design is running now. Earlier, footing design part 8. Okay. Actually, okay, it will take, advertisement is coming. See, ads are coming. Okay, skip ads. Now you can hear voices. Nothing can be done.
Based on bending. See. Stress will come. So, remain class question.
This way you should ask. See, 160.3. I don't know what values you are giving. See, this is 160.3. I am hearing my own voice. Hey, keep quiet. I am hearing my own voice. 160.3 kilonewton per meter square. Here pressure is.
Even though I told I am not explaining, length is 4.1, widthwise is 3.6, thickness will decide at that time.
See, my own voice. Why should I hear it?
Person's name I will not.
140.
He will be knowing.
It is 140.
Just a minute.
See, I asked pressure there. You are telling pressure here. Kn per meter square.
This message to my
1
in IS 4.6
See,
2000 only 3 grade.
140 to 160.3. Okay, sufficient. Leave it now. Now, I cannot see charts box now. See, leave it now. Same way. I will not ask you now. This way also we got pressure diagram. See, here pressure is more. This is the pressure diagram for this side. This pressure is average of these 2 by 2 here. Alright, average is by 2 only, sorry. Sum of these 2 by 2 or average here, sum of these 2 by 2. For widthwise bending, average this way. Now, this is the pressure diagram. I put that way. Then I do not want this value now. These values are entered. Then I told there is one cantilever here, one cantilever here, one cantilever here. For this cantilever, pressure diagram is like this way. For this cantilever, pressure diagram is, see, that is this pressure, somewhere here pressure, somewhere here pressure, and this pressure. Is now. Then we decided what? That side higher pressure, this side lesser pressure, projections equal, so you get out. I told you, you are not required. Okay, now, I want these two pressures. Even if you type, I cannot see now. Why? I am in my own channel. Okay, I will see my own channel. It is 155.3 here. 155.3 kN per meter square here. And here it is 136.8 kN per meter square. Okay, now I told you later other things. I remove it now. This will bend like this. This will bend like this. So tension at the bottom, tension at the bottom. This will bend like this. This will bend like this. Here also tension at the bottom. Or common sense. That is not required. See, footing, isolated footing slab will bend like this. So it will be fully sagging. So everywhere tension at the bottom. Therefore, for widthwise bending, you require this steel. You need steel here. For lengthwise bending, you need steel here. This is your AST for lengthwise bending. See, what you provide there, provide same here also. I'll write here. This is your AST for widthwise bending. Okay, this much I told. Now, that's all. Then I will tell you, after all this one, you first consider lengthwise bending. See, first we considered lengthwise bending. And one more thing I told, I should stop this one. Even though load is kilonewton per meter square, when you take 1 meter strip, it is actually writing is kN per meter square. You should think it as kilonewton per meter. That meter square is not there. If someone asks the doubt, why means no answer from me. It is told 100 times. Even though it is kilonewton per meter square, it is kilonewton per meter for a strip of 1 meter. Sorry, now I will not tell. Okay, now anybody will tell later, sir, that kilonewton meter square is there. I will tell, don't come to my class. There is a limit for explaining. Start. Now, lengthwise bending, we got, what is the MU you got? Maximum MU. Lengthwise bending MU. How much you got? Again, instead of asking you, better I only see my channel. Better I only see my channel. See, my own voice I am hearing. That is, I am teaching to myself only. I want factored value. Lengthwise bending, MU means factored. I should not tell. MU, lengthwise bending. I can see 320, not visible properly. Light problem. I will go for, see, there is a light problem here. Brightness problem. See, these are all should have been avoided if you have given me correct answer. You have unnecessarily wasted time. 323.1. 323.1 kilonewton meter. And for widthwise bending, your MU is, widthwise bending, I have checked now. Where is it? Widthwise bending. See, again I have seen my own video.
It is for what load?
Abba. No.
That is into 136.
See, how much time is wasted because of your non-involvement. See now, I am searching my own class and searching for the values. Because, see, this only has completely given me no confidence. You are not giving the value given by me. Now again, I have searched, where is it? Where is the mu? See, I have to go further, search for mu.
Show me that he knows something.
I don't know. This is, you are only responsible for this one.
Now today I'm happy.
Lengthwise bending, 1 minute. Someone will start wondering what is happening. 215.4 into 1.5. 323.1 correct. Widthwise bending, where is it? Now see. Even if you type, I am not seeing because why? I am in my channel.
Tell me, actually better.
I cannot see the value here.
Better take
See, I am offsetting myself only.
75%.
211.6. 211.6 into 1.5 is 317 point, I don't know. 317.4 looks like this the BM. 1 minute. How much struggling, see? Okay, I think most probably correct. No, can leave it now. I am leaving my channel now. I am leaving my channel. Okay. ನೋಡಿ, I am seeing my own scolding there. Anisha. This is all because of what? Your no cooperation. If you have taken a screenshot,
Your no cooperation.
ನೋಡಿ, ಬಂತು.
Taken a screenshot.
If you had taken a screenshot, all this problem would have been eliminated. Okay, what to do? Helpless. Now see, I am telling 317.4. Some are telling 317.55. Okay, 317.6. I put it. Now what you have done is, okay, now I am back in the chat. I can see now. What all you type, now I can see. See, this way if you do, it is very difficult. See, later, when we go to software, if this is the way, of course, at that time, general public will not be there. Only those who are registered, they will be there. There, I will talk much more harshly. Here, because it is a general public video, so I do not want to talk very harsh. There, I will talk harshly only. I will tell, suddenly I will threaten, I am going to close the class. It happened earlier once. See, at least you take a screenshot of the critical values. Better you write the solution, you write in a paper. Okay, leave it now. Now, you found these two bending moment, then we decided what is the depth of the footing slab. See, we considered the higher bending moment and found the depth required for, effective depth required for bending moment, factored mu, equating mu to mu limit, then adding cover, etc. You got the overall depth D required. Then I told you better increase at least by 75%, better up to double 100%. But what happened is, just to show you, if you don't increase, what happens? Last time, first time I took small depth, you paid heavy penalty. Remember, heavy penalty. The shear stress was almost 3 times of the permissible or allowed stress. If you have 1,000 rupees in the pocket, bill came 3,000 rupees. Utterly, horribly unsafe. Then, finally, tell me, after revision, tell me, after revision, what is the overall depth you have taken? Now, if you don't give the values, once again I have to go to my old video now. If you don't give the value, once again I have to go to old video. Tell the answer. What is the capital D provided? Now, if you don't answer, again I have to stop here and go to YouTube and search my own class. No answer. What is the capital D provided? After revision. Answer illa. This way, if you participate, live class has no meaning. 750, okay. 750 millimeter. Then we took 16 tor and tell me what is the D provided. I already told you D provided is, we considered 2 directions, different D will be there. For safer side, for both of them, we took the same D, which is a lesser D, to upper layer of bars. Somebody can comment, how you can tell D same for both? I will tell him, don't talk in front of me. I told it earlier. If he does not go through class and tell these are different for this one, I will tell you don't know subject. I told that one, these are different, but for safer side, because in the site, how you arrange the steel, they may put other way, not spacing. They may put this bar first and then this bar, or they may put this bar first and this bar. So danger. So what you do, where least D is there, take that D, so that let them place whatever they want, you are safe. How much D? D, 676 millimeter. Okay. Now, then we checked for punching shear. See, checked for punching shear. Punching shear. Which earlier we took D lesser. It came unsafe. Go to that class. It came unsafe. See, first you checked for it. You took a lesser D. Check for punching shear. Terribly failed. Then we changed to 750. Then punching shear came what? Safe or unsafe? Tell me. It came safe in punching shear or unsafe? What happened? We got safe or unsafe? In punching shear. What happened? We got safe or unsafe? In punching shear. What you got? Safe or unsafe? ಇಷ್ಟೊತ್ತು ಬೇಕಾ ಸೇಫ್ ಅನ್ಸೇಫ್ ಅನ್ನಕ್ಕೆ ನೋಡಿ waiting for a long time. When you check the second time, it came safe. Okay. Somebody may ask, how safe? Go to that class and study. Class, today is class part number 9, I think. Go to part 1, part 2, part 3, part 4, study everything. Do not come in between and comment it. If you understand everything, then ask me whatever you want. Okay. Now, punching shear check part. Immediately make a note. Remember, I will not tell again. Make a note. This I told you repeatedly earlier. Punching shear check fast. There is one more shear which is not punching shear, which is shear which will cause diagonal tension cracks, or you can call it wide beam shear or one-way shear, or simple language, our usual shear, mamuli shear. Okay. That check we cannot do, because if you want to check that shear, you need percentage of tension steel provided to get tau C. Therefore, that also is equally critical. Equally critical. Remember, I proved it earlier. See the example. In the earlier example for axial load design, we got unsafe there. We got punching safe. That became more than punching. That told, if punching is what you call, punching is a tiger, it told I am like an elephant. Why? Or lion and tiger. Elephant is more powerful. So it told I am furthermore ferocious. Okay. Therefore, you tell it, you wait. Let me, therefore, first you finalize what? First you finalize what? Finalize AST in both directions. And then lastly check for that shear. Then one important concept is there. I will tell you today and stop. This problem over. Okay, start. Note over. Now, next is calculation of longitudinal reinforcement. That means AST. Over. Start. First, we have mu equal to 0.87 Fy into remaining you write if you want to understand. I am not writing. See, in usually YouTube classes, people write every time everything. Why? They want people to understand more. I also want people to understand more, but I want people who are not studying previous class not to understand. My class has got value. Therefore, I will tell, someone will tell, what is going on here? See, if that person is not writing, you have not gone to earlier class, no, then go there. Okay, start. First, remember, we are using M25 concrete and FE 500 steel. Tell yes or no. If I remember, you are using M25 concrete and FP 500 steel. Yes or no? No, I can hear my voice very clearly. No, lag because of your net problem, I think. No, lag is not there. Lag is not there. I can see. Even I'll check there also. Absolutely no problem today. Yes, no problem. It is running. We are using M25 concrete and FP. See, I forgot now. FP 415 or 500? Tell fast. No, tell fast. See the question. Otherwise, what will happen? Someone will comment. When he started the question, he took FP 415, FP 500. Suddenly he changed to FP 415. No, I do not want such negative comments. Tell me, only one person not sufficient. Some more has to answer. Otherwise, again I have to go there now. Otherwise, once again I have to go there. I think FP 500, I think. See. Okay, now I'll do one thing now. I have to see. Others are not responding. If one more person tells which steel, I will be confirmed. See, no answer came. Only one answer came. One answer, I can't depend. One answer, I cannot depend. Not that I will put a mistake on him. Later, suddenly someone will tell, sir, it is FP 500. Then I will stop the class only. Then I will be forced to stop the class. ನೋಡಿ ಈಗ FP 500 ನೋಡಿ ಯಾವುದು ಕರೆಕ್ಟ್ ಈಗ which is correct. See, such things should not happen because this is a continuation of the class. When I started for problem, I have given data. That data should be maintained. Okay, FP 500. See, therefore, see, what happens is, if you give wrong, you should observe what is given earlier. Otherwise, this recording of this class will be there in YouTube permanently. So people are there who want to find mistake. They will tell, he takes once FP 415, FP 500, halfway through, he will go to FP 415. He does not know subject. See, people are there. Okay, start. Now, see, when you decided the depth of slab, you considered whichever is higher BM. Why? Depth you fix based on higher MU. But, right, reinforcement you have to give separately for both. Actually, see, both are almost same. Tell me why both are almost same? Almost same because we maintained same projection both sides. This I told you. Anyway, start. First consider lengthwise bending. Lengthwise bending. Start. Substituting MU. Where is MU? MU is here. 323.1 into 10 to the power 6 Newton millimeter equal to 0.87 into Fy into AST. AST is unknown. AST is unknown. Be careful. Okay. If I want 0.87 Fy into AST into effective depth D is 676 into bracket 1 minus AST into Fy is 500 divided by FB is, I told you, everything is 1 meter strip. B is 1000, D is 676 into FCK is 25. This will give a quadratic equation, solve and take least value, tell the answer. What is the AST required for what? For lengthwise bending. Answer. It comes in millimeter square. What is the AST required for lengthwise bending? Answer. 1136.63. Correct answer. At least one more person, if he gives the answer, I get confidence. Otherwise, suppose a mistake is there, that mistake will remain permanently there. No, others all should actually participate and give your answer, so that if two people give same answer, I get confidence. Factored load. I took factored only here. I took factored bending moment only I taken. Yes, okay. 1136.63. 1136.63 mm square. This is for 1 meter strip. I will not write. Everything is for meter strip. Okay, start. Now, as per IS code, minimum steel in any direction means what? Any direction means what? That is for both lengthwise bending or widthwise bending is equal to 0.12 by 100 into B is 1000 into D is 750. I am not explaining what is going on. Why? If you do not know this one, you are wasting your time attending my class. It has been already told thoroughly earlier. 0.12% of B into capital D. Okay, one more thing. If you earlier in the slab, how many times you used it? 1000 times you used it. Somebody can tell, no, slab you have taken in Zoom class most probably, public you are not done. Yes, I had done it earlier in the series of classes, maybe footing part 3 or 3. His answer, no, I have not gone through. Go there then. Answer. How much? How much answer? Minimum steel. You are not giving minimum steel. Is 900 mm square. Therefore, see, what is the AST to be provided? To be provided for lengthwise bending. Tell the answer. Requirement is 1136.63. Should not give less than 900. How much you have to give? Minimum 1136.63 mm square. Remember, in case the requirement comes less than minimum, you have to provide minimum. Okay, now I will continue here now. We have taken 16 torr. With 16 torr, what is the spacing? Spacing equal to pi by 4 of 16 square divided by 1136.63 into 1000. Answer. This will give spacing for 16 torr. What is the answer? Spacing for 16 torr. Part spacing. Spacing for 16 torr. 176. ಯಾಕೋ ಡೌಟ್ ಬರ್ತಾ ಇದೆ ನನಗೆ ನೋಡಿ. Calculate not on.